Now what we want to be able to do with parametric equations is be able to find the derivative first, second, and also be able to find the equation of a tangent line like we did in the very beginning. So in parametric form, since you have two separate equations in terms of a third parameter t, if you take the derivative of x with respect to t, you're going to get dx dt. And if you take the derivative of y with respect to t, you will have dy dt. So when we talk about the slope of the curve, we still want to create dy dx. So the way that we're going to create dy dx in parametric form is it's going to be dy dt divided by dx dt. Now the second derivative is where it's a little bit tricky. The second derivative, again, notice the notation, you're taking the derivative of y twice with respect to x twice. So you are going to take the derivative of the first derivative, dy dx, but then you will divide by dx dt again. So let's go through a couple problems to see how we're going to do this parametrically. So dy dx is dy dt divided by dx dt. So dy dt is going to be give me negative sine of t, dx dt will be cosine of t. That's it. Okay, so your answer, it will be in terms of t. Okay. The next one, let's go ahead and do first derivative. So dy dx again is dy dt divided by dx dt. So dy dt is going to be 6t minus 2. dx dt is going to be, I'm going to bring down the 1/2, so really the 2's will become 1, reduce the power by 1, so it becomes t to the negative 1/2. Now, if I just ask you for dy dx, then this is it. I would just leave my answer as is. But since I'm going to have to find the second derivative, this is where I probably will simplify. So I'm going to bring that negative exponent to the top and multiply it out and write it like this. And the reason why I'm doing this is this will make it simpler when I have to get to my second derivative. So to find the second derivative, you're going to take the derivative of the first derivative, so take the derivative of this, so bring down the power, so that becomes 9, reduce the power by 1. Same thing with this one, bring down the 1/2, reduce the power by 1. And you will divide by, look at this notation, you're going to divide by the dx dt again, and dx dt was t to the negative 1/2. Now again, if I just ask you for the second derivative, you can stop there. If you simplify this, it actually does simplify nicely to 9t minus 1. Okay, last one here. I want to find the slope. So anytime they talk about slope, you're always thinking dy dx. So again, dy dx is dy dt over dx dt. So dy dt is going to be, leave the 1/4 in the front, derivative of t squared minus 4 is just 2t. Derivative of dx dt is going to be bring down the 1/2, reduce the power by 1. And I'm going to simplify this a little bit. Notice 1/2 here, 1/2 here, bring the negative exponent to the top, so this becomes t to the 3/2. Okay, now I want the slope at a particular point, so I actually want a number here. This is your xy. It is a point on the graph. This is not your t, but my slope is in terms of t, so you have to find the corresponding t value that matches with this point. You can pick either point to use. Let's use the x-coordinate. Well, I have an equation in terms of x's and t's. X is square root of t. I know my x value is 2, so what does the corresponding t have to be? T has to be 4, so if I plug in t equals 4, 4 to the 3/2 will give me 8. So this is my slope at that point.